Welcome back to the channel. Let's dive into the Earth Fault Monitoring System. This system is arguably the single most important safety feature on a vessel's electrical network. Unlike land-based systems that are often earthed or grounded directly to the Earth, most shipboard low-voltage power systems are designed to be ungrounded or insulated. This design is a massive safety and operational advantage, and the Earth Fault Monitoring System is what makes it work. In an insulated system, the neutral point of the generator is intentionally not connected to the ship's metal hull or structure, which serves as the earth. This means that if a single earth fault occurs, where one phase of the power system accidentally touches the ship's metal structure, the electrical circuit is not completed, and a large fault current does not flow. The power supply can therefore continue to operate uninterrupted. This is critical at sea. Imagine losing a vital pump or navigation system simply because a single wire insulation failed. The ungrounded system allows the ship to maintain operation even with a single fault, giving the crew time to locate and repair the issue without a service interruption. However, operating with one fault means the system is now inherently vulnerable. If a second earth fault occurs on a different phase before the first one is cleared, a massive short circuit is created between the two fault points through the ship's hull. This creates an enormous fault current, a fire risk, and will inevitably lead to a total blackout and the tripping of protective devices. This is why the Earth Fault Monitoring System is so critical. Its job is to detect that initial single earth fault immediately before a second, catastrophic fault can occur. The monitoring device, often called an earth leakage indicator or earth fault relay, is constantly measuring the insulation resistance of the entire power network relative to the ship's hull. It does this by injecting a small, low-voltage signal between the phases and the earth. When a fault occurs, say moisture ingress causes a cable's insulation to degrade, the insulation resistance drops. The monitoring system detects this drop and immediately activates an alarm on the main switchboard and in the engine control room. The alarm is typically audible and visual, clearly indicating which system or section of the bus bar is affected. Upon receiving this alarm, the engineering crew must act swiftly. The procedure involves locating the faulty circuit by methodically checking load circuits one by one. Once the faulty circuit is identified, it must be isolated and de-energized until the fault is repaired, thus restoring the system to its safe, unfaulted state. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.